Hello, good afternoon my dear students. Welcome to one more amazing session from Sri Chaitanya Academy Infinity Lane NEET YouTube channel. How are you all doing? So, in the series of NIRMAAN 1.0, we are completing the total syllabus of a NEET examination. In the chemistry series, we completed general organic chemistry, hydrocarbons, alkene, alkyne, alkyne and aromatic compounds, and multiple choice questions based on hydrocarbons also. Now, in this next topics we are going to discuss about the chemical bonding. I just want to go with the fragmented version, because in the NEET examination the fragmented version is very important, what is scientifically proven for the based on the 2026 NEET examination. So I suggest all the students study the total topic as a fragmented, and you just connect one dot to the another dot. So connection of these are very important, because when you see the NEET 2026 paper, especially for organic chemistry, it is slapped like anything. One topic is connected to another topic, and a question is framed within the range of NCERT, and a question is a multi-concepted connection. So students, those who are online, please like the session and share with your friends and subscribe to this Infinity Lane Sri Chaitanya Academy NEET YouTube channel. So आगे आने वाले के जो सेशंस है आपको पता होगा. And chemical bonding, in this session I just want to take the hydrogen bonding into the consideration, because this is the hydrogen bonding is the deciding factor, not a direct question from the NEET examination, but also it is going to connect the total P block elements and organic chemistry, sometimes general organic chemistry, everything is going to be connected here, right? Come on, let's see. In this chemical bonding, hydrogen bonding, here the pointer I just want to say, so there is some technical glitch. Hold on a minute and I'll yeah. Now, sorry for glitch here, the hydrogen bonding. So what is the hydrogen bonding? Does every hydrogen can form hydrogen bonding? No. So when you see a bond between hydrogen to halogen, because of the electronegativity difference between the hydrogen to some electronegative atom, like just like it could be a nitrogen, oxygen and a fluorine. So there will be a temporary negative charge, and there will be a temporary positive charge which is resulting in a dipole. So it is going to be a polar molecule, so that there will be attraction between, electrostatic force of attraction between this positively charged hydrogen and the negatively charged electronegative atom. And a hydrogen bond form करने के लिए condition होगा क्या? So condition का पहले वाले हैं highly electronegative, it should be highly electronegative, and दूसरा condition, it should be a small atom, small atom. So I want to tell you a short version, only oxygen, nitrogen and fluorine is going to form hydrogen bonding, and it is represented by a dotted line. So HX, 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 there is a weak electrostatic force of attraction between the hydrogen and electronegative atom, so that is indicated by dotted line. And this hydrogen bonding is of two types, within the molecule and between the molecule. We'll see hydrogen bonding, it is a special case of dipole-dipole attraction. If you say hydrogen to fluorine and hydrogen to fluorine, there is a partial negative charge and a positive charge, and there is a hydrogen bonding. The same thing can be seen, my dear students, HCl and HuCl, and it is a partial negative charge and a partial positive charge, a negative charge and a positive charge. ये दोनों को बीच में अभी आने वाला है. Do you say this is hydrogen bonding? No, to say this hydrogen bonding, you have to say 3 to 10 kilocalories, and the energy value is less than this value, so it do not comes under the bucket of the hydrogen bonding. So molecule with hydrogen atom attached to the highly electronegative atom. Actually, the hydrogen bonding is a special case of dipole-dipole forces. And the definition of the hydrogen bonding here, attractive force which binds the hydrogen atom to one of the molecule of the electronegative atom. Just like मान के चलो ये फ्लोरीन, ऑक्सीजन, नाइट्रोजन, कंडीशनली क्लोरीन होता है, एक्सेप्शनली क्लोरीन कभी कभी आएगा, and that bonding is known as hydrogen bonding. And this hydrogen bonding, let us see the implementations and the technicality of this. So बच्चों, here main constituents for the conditions for the hydrogen bonding, NEET examination. So statement based questions can be asked. The electronegative atom should be very small, and just like fluorine, oxygen, nitrogen is able to form the hydrogen bonding. And also you can see the strength of the hydrogen bonding is the weakest, and of course it is one of the type of van der Waals forces. And you know, ionic force of attractions, ionic bond is as strong as compared to the covalent bond as compared to the hydrogen bond. So hydrogen bond is the weakest. Among the covalent bond and the dative bond, you see the polar bond can be easily broken than the non-polar bond. Okay, anyways, you can see hydrogen bonding, alkali metal hydrogen fluorides, you can say very strong hydrogen bonding can be seen here. So I just want to say KHF2 is existing. Okay, so that very strong hydrogen bonding occurs in alkali metal hydrogen fluorides, the formula MHF2. You can see HF, KF and HF is a covalent. Okay, partial negative charge and a partial positive charge, K plus and F minus, there is a hydrogen bonding. And the bond length here, you can see it is X and it is going to be Y. The bond length of X is equal to Y, which indicates strong evidence of existence of a hydrogen bonding. And moving ahead, so the types of hydrogen, we'll see the questions at the end of the session here. So those students, please follow the topic and write the noteworthy points. So in this channel, we are not promoting anything. We are giving a genuine subject and we ask you to students to follow the same, and that's why those who are online, please like the session, that's it. And those who are still not yet subscribed, you can subscribe it. If we want anything extra out of this current context, please let us know so that we can explore the subject to the highest, and we can provide you as you requested in this YouTube channel. Just knowledge transfer is happening. So come on, my dear students. So I just want to say hi, good afternoon. Uchiha. So I don't know, I can't pronounce your name. Come on, it's a live interactive session. If you just say anything, I'm going to take your name as well. Right? Students, hydrogen bonding, you can have intermolecular hydrogen bonding, you can have intramolecular hydrogen bonding. Sometimes homo-intermolecular or hetero-intermolecular can be seen. So within the molecules, you can say within the same type of molecule, it is homo-intermolecular, and if it is two different molecules, that is called as hetero-intermolecular. Okay, good afternoon, hi. And let us talk about example of intermolecular hydrogen bonding, and their applications also we'll see here. So if you see water molecule, hydrogen, oxygen and hydrogen, hydrogen, oxygen and hydrogen. there is oxygen is a partial negative charge and a partial positive charge, partial positive charge, partial negative charge, partial positive charge, partial positive charge. So between that there is an attraction force existing between these is called as intermolecular hydrogen bonding, and because of this intermolecular hydrogen bonding a lot of applications are there. We'll see that also, children. In this YouTube channel you see all the good stuff I wanted to give you. Hydrogen bonding in the HF molecule. HF molecule, you see it exists as a zigzag format. Zigzag format. You can see HF, okay, HF. There is an hydrogen bonding. There is a hydrogen bonding in the solid as well as in liquid state. It is existing as HF for the n times. So sometimes you can say H2F2 as well. HF is a weak acid because of this hydrogen bonding. So you can say example of intermolecular hydrogen bonding, acetic acid you can say. So in the solid and liquid state you can say acetic acid. So CH3, I just want to write the board here, CH3 and C double bond O and OH and CH3 and C double bond O and OH, and there is intermolecular hydrogen bonding is there. The intermolecular hydrogen bonding. So this particular concept is used in solutions and colligative properties. When acetic acid dissolved in benzene, it undergo dimerization. So it exists as a dimer. So when acetic acid dissolved in the water, it ionizes. 1.5 factor is going to be greater than 1, and acetic acid dissolved in the benzene, it dimerizes. It is going to 1.5 factor is going to be less than 1. Remember? So this kind of noteworthy points. Again I am telling you, carboxylic acid, acetic acid in C6H6, 1.5 factor I value is going to be less than 1. Acetic acid in water. So in this case I value is greater than 1. Dissociation takes place, association takes place. As I promised you, in this particular session we are going to discuss only about the genuine version of the discussions. Yes? So please give me a thumbs up and fire emoji in the live chat so that session का energy भी बढ़ जाता. बच्चों, example of intermolecular hydrogen bonding. So I just want to say boric acid, P block elements, boric acid, He3BO3, boric acid you can see, He3BO3. So boron, OH and OH and OH. Now you can see this hydrogen bonding version. You can see the hydrogen bonding. So it is going to form a hexagonal sheet like a structure. Yes or no? It is going to see. So the overall structure is like this. Crystalline state, the boric acid exists like this. Each boric acid is associated with, you can see, if you see this, each boric acid is associated how many hydrogen bondings? 1, 2, 3, 4, 5. You can just count as many. So NEET examination is going to predict this kind of things, right? Are you getting or not? Clear? If you have any doubts, please let us know. Right. So let's see. Example of intermolecular hydrogen bonding. So alcohols also do have hydrogen bonding. Alcohol dissolve in the water. Okay, hi Surya Pratap. Now the session is going so dull. Now you make the session too energetic now. So what is ethyl alcohol? Oxygen, okay, hydrogen, this is going to be C2H5, And what is water? This is your going to be water. So there is a hydrogen bonding. There is a hydrogen bonding here, right? Cross intermolecular hydrogen bonding is there. That is the reason why ethanol is going to soluble in the water. Surya Pratap, how are you doing? How are you doing? Now, ortho-meta positions of the benzene you need to know. So, this is the benzene. If these two groups with respect to these groups are said to be 1, 2 positions. So, G2 is ortho with respect to G1, and this is G stands for a group or an atom, and this is called as 1, 3 positions. So, G2 is meta with respect to G1, and G1 and G2 you are going to say this is going to be 1, 3. This is what is called as a para. So, 1, 4 I want to say 1, 4. So, 1, 2 positions said to be ortho positions, and 1, 3 positions is said to be meta positions, and 1, 4 positions is said to be para positions, right? Now, in this case, if you say intramolecular hydrogen bonding is the hydrogen bonding within the molecule. You can say this is ortho-nitrophenol. What is this? Look at this. This is your O and H phenol, and the nitro group is here given like this, ortho-nitrophenol. And there is a hydrogen bonding here. Within the molecule hydrogen bonding is seen. Are you getting or not? Surya Pratap. So this is what is called as a within the molecule, that is called intramolecular hydrogen bonding. And some more examples I just want to give you. Salicylaldehyde, para orthohydroxy benzaldehyde is called as salicylaldehyde. You can see salicylaldehyde, C double bond O H. This is a benzaldehyde, and this O group, and this is a H. So there is a orthohydroxy benzaldehyde is said to be salicylaldehyde. So you're going to see this within the molecule, intramolecular hydrogen bonding. And also you can see chloral hydrate. Actually, two OH groups do not exist on the same carbon atom, never and ever. This is an exception in the entire chemistry. Chloral hydrate is the one example. Trichloroacetaldehyde. This is CCl3CHO, trichloroacetaldehyde, and whenever it react with this, you are going to get CCl3CHO dot H2O. So this is a reaction, and this is a reversible reaction, and because of this chloral hydrate, it is going to be stable equilibrium favors in the forward direction because of intramolecular hydrogen bonding. This intramolecular hydrogen bonding is seen here, C, okay, and Cl and Cl and Cl and C, and it is going to be O and H, and it is going to be O and H, and you can see there is intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Are you getting or not? Clear? This is what is called a chloral hydrate. Trichloroacetaldehyde react with water. Reaction Kc is going to be greater than 10. Okay? Now students, let us see some more examples here. Hi Surya Pratap, if you have any doubts, please let me know. So hydrogen bonding usually doesn't form hydrogen bonding due to their low charge density. This is the one. Chlorine usually do not form, but chlorine in both orthochlorophenol and chloral hydrate, hydrogen bonding is there. Hydrogen bonding is there because of the high charge density they are going to form. So in the NEET examination, you will be demanded which of the following can form hydrogen bonding, which of the following do not form hydrogen bonding. So these are certain exceptions. You can see orthochlorophenol, yes, hydrogen bonding is there. Right. Now moving ahead, hydrogen bonding dependency on physical state of the compounds. As magnitude of the hydrogen bonding depends on the physical state, you can see hydrogen bonding is more effective in the solid state as compared to the liquid state than the gaseous state. So that's what I want to say here. So intermolecular hydrogen bonding, few organic compounds could be non-polar or soluble in water in the polar solvent due to hydrogen bonding. That's the reason why alcohol is an organic compound. When you dissolve in the water, soluble because of the hydrogen bonding. Acetic acid is soluble in the water because of the hydrogen bonding. So there is a cross hydrogen bonding between the alcohol molecule and the water molecule, can be seen like this. Between the acetic acid molecule and the water molecule are seen in this way. Okay, and as well you can see, yes, some alkynes, terminal alkynes. So an example, acetylene C2H2 is highly soluble in acetone due to hydrogen bonding. You know, acetone do not have, this is propanone is otherwise called acetone, do not have hydrogen bonding, and acetylene means ethyne do not have hydrogen bonding. Because of the sp hybridization, this carbon is going to have extremely high electron negativity, so that it can pull the electrons, make sufficiently positive charge for this hydrogen, makes responsible for the hydrogen bonding here. So it's a super important. You never see this kind of examples in the textbook, but in this live YouTube channel, my dear children, take this as an advantage. It can help you a lot. Okay. Now, solubility of alcohols and ethers. Alcohols is soluble in water, ethers are not. Okay. And because these alcohols can have a hydrogen bonding with water. Okay, hydrogen and oxygen and hydrogen. This is going to soluble like this, hydrogen and hydrogen. But whereas an ether do not form hydrogen bonding, that's the reason why you can say solubility of alcohols is greater than ether. Right? And moving ahead here, solubility, intramolecular hydrogen bonding. Yes, this is your orthonitrophenol. So because of this internal hydrogen bonding here, this is a chelate formation. Hydrogen, this hydrogen is not available for ionization. Okay, for other molecules. So hydrogen bonding with water molecule is not possible. Solubility is very less. It is insoluble in the water. Insoluble in water. In water. Of course, the other way I can say this orthonitrophenol is going to be steam volatile. Steam volatile. So when the phenol is nitrated with dilute nitric acid, you are going to get the mixture of orthonitrophenol and paranitrophenol, and this orthonitrophenol, paranitrophenol are separated by steam distillation process. So you are connected to the practical chemistry as well. Are you getting or not? My dear students, those who are online, please give me a thumbs up and fire emoji so that we can get some more rapport. It is not a radio session, it is not a recorded session, it is a live interactive session. Okay, if you have any doubts, so please ask in the chat box, and if you are watching the recording version also, you can mention in the comment box. Please, those who are online, like the session, share with your friends, and subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel. Okay, come on. So effect of hydrogen bonding in a physical properties. So you have solubility. As hydrogen bonding increases, solubility increases. As viscosity, as hydrogen bonding increases, viscosity increases. जैसे आपको glycerol and boiling point, hydrogen bonding increases, boiling point भी increase करना है. And physical state, because of the hydrogen bonding, the gaseous state become liquid state, liquid state becomes solid state, and acidic as well in its basic strengths. So the total chemistry study is impacted by the hydrogen bonding. When you talk about the general organic chemistry, the order of the effects, When the hydrogen bonding is the strongest effect, then you can say steric factors, then you can say aromatic effect, then resonance effect, then hyperconjugation, then inductive effect. Like that you have to say. Now talking about the hydrogen bonding, boiling point is directly proportional to the extent of hydrogen bonding, which is intermolecular hydrogen bonding. And say if you see the group of 15 elements, as molecular weight increases, hydrogen bonding should increase. This is the expected one. But due to hydrogen bonding, the actual one is going to be ammonia comes here. Ammonia has intermolecular hydrogen bonding. And PH3 phosphine is the least boiling point, the least boiling point, and most volatile. Understand? And group of 16 as well. What is the expected boiling points is this, but due to hydrogen bonding, water is going to be the actual one is going to be water is highest due to intermolecular hydrogen bonding. So these are the pointers that is very, very, very important for NEET examination. Fine. Now talking about the group of 17 elements, expected HF should be least, but HF actual is going to be, it is given, yes. Now I want to say hydrogen bonding, which of the following molecules has a higher boiling point? You can say ortho-para and para-nitrophenol. You tell me. Ortho-nitrophenol has intramolecular hydrogen bonding. Para-nitrophenol, I just want to say here, para-nitrophenol appears like this. And one more molecule I just want to give the reverse way. There is a hydrogen bonding here. Due to this, para will be having high boiling point. That's what ortho-nitrophenol intramolecular hydrogen bonding and para-nitrophenol intermolecular hydrogen bonding makes it more boiling point. Isn't it clear? And also arrange the following molecule in order of their boiling point. So water is going to have 4 intermolecular hydrogen bonding with neighboring water molecules. Then CH3OH, because of the alkyl group, this hydrogen bonding extent is less. Then ethers actually don't form the hydrogen bonding. So I want to say, why does ice float on the water? On freezing, what will happen? The liquid state water molecules are held together by weak hydrogen bonding, but in the hydrogen bonding in the solid state there is a strong hydrogen bonding. As a result of this strong hydrogen bonding, you are going to see the water molecule tetrahedrally, this is going to be hydrogen and hydrogen. It is going to have tetrahedrally, it is going to have hydrogen bonding, 4 intermolecular hydrogen bonding makes it is open cage like a structure. Because of the open cage like a structure, I just want to say, on reacting in solid state, hydrogen bonds become stable, arranging the water molecule far apart, so that volume is increased. So this causes density of the ice is less than water. This makes the ice has to float on the surface of the water, right? That makes it water is still in the liquid state beneath the ice. That makes the life even in the glacier in this Antarctica areas, still it is going to withstand. So that's what tetrahedral hydrate formation again, hydrate formation. Higher hydrates are hydronium ion with the formula of H3O plus, mean to say H2O for the n times it is going to be there. Hydrate H plus H2O n times, it is going to be like this. This is what is called as a hydrate formation. And also effect of bonding, we already seen this. Acidic strength ease of removal of H plus ion, basic strength ease of removal of OH minus ion. Okay, these are all the things we can study. We have some questions as well. I just want to discuss. Among H2O, H2S, H2SE, H2T, the one with the highest boiling point, can you tell me? So NEET examination, such type of questions can be asked. Come on, who is going to give the answer? Bacho. That is nothing but H2O because of hydrogen bonding. You see the framing of the question. It is exactly matches with the NEET examination, right? That's great. And also the strongest hydrogen bonding is present among the following. Hydrogen bond strength is directly proportional to electronegativity. So this is the one. Understand? Fine. Answer is going to be C. And also we will see here which of the following does not exhibit hydrogen bonding. Alcohols will exhibit, carboxylic acid will exhibit, amines will exhibit, amide will exhibit, and acetone alone do not exhibit. Acetone can form hydrogen bonding if you mix with others. Okay. Solutions and colligative properties. Acetone and chloroform, negative deviation from the Raoult law. Remember? Yes, the answer is going to be third one. So, bacho, here one more. What is the correct order of the boiling points? H2F, HF and NH3. Super question. Typical NEET question. Can you answer this typical NEET question? It is going to be H2O has the highest hydrogen bonding, then HF, then ammonia. And moving ahead, some more questions we will discuss in the next class, and we will be having dipole moment and intermolecular forces in the next class. Till then, you just study and revise. If you have any doubt, please let me know. And I am done with my session today, and we'll see you. Yes. Thank you for the day. So please like the session and please share with your friends and subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel. Thank you. Hope you love the session. Thank you very much.